that your code, the code you're writing, is like blueprints of your application. They can be analyzed through static analysis, for example. But once your application is running and deployed, it becomes a black box. So you don't have any insight of what's going on in there. A profiler like Blackfire gives you sonic glasses, let's say, to understand, to be able to see what's actually going on when your application is running. So seeing inside the black box. And for this, I have this browser extension, which I installed in my Firefox. It's also available for Chrome, of course. And I have this big profile button, which I'm going to click in. Of course, before I had been authenticated on Blackfire website, because one of the particular things of Blackfire is that you can completely safely run it in production. And you can run it in production because I said that you have a PHP extension to install within PHP, and this extension will really remain completely inert unless you're triggering a profile. And when you're triggering a profile, there's the small overhead that will inevitably happen will only occur for yourself, and will not impact any other end users. So, and another point, because as you can run it in production, you need to be sure that only authorized people can profile your application, of course. So that's why you need to be authenticated to Blackfire, to Blackfire.io. And what it's going to do when I will click on profile, it will first check if I am authorized to run. So here I'm running locally, but if I run on a production website on Blackfire.io, for instance, I will be able to profile myself, but you won't be able to do so. So clicking on this will trigger a process here. And it's very slow because all the resources are dedicated to the screen sharing and the video. So what it's going, it's sending 10 different requests to your application in order to see what's going on and to average the different calls. So let's. Yeah, you can see here that it took, in average, 1.69 seconds. Well, usually it's a bit faster. We have a lot going here on my local machine. And so this is here, the stopwatch. We call this the wall time. So the wall time here, the summary, is a summary of your the time spent between the very beginning and the very end of your application. Here is the different dimension and you have also different there. So this one is the input-output time. This is the CPU time. Yeah, you can see here. So the CPU time is the actual computation time, and input-output time is the time that PHP is waiting for something outside, like the file system or network. For example, here we have a lot of SQL queries, so there might be here some time spent waiting for the server to reply to your SQL queries. We have also the memory, the network consumed, and external HTTP request, and SQL queries. So that's the whole summary of everything. Now we have two different visualization. The first one is the timeline, and the second one is the call graph. So the call graph is the most common one. and I'm going to first click on the timeline to have an overview of it. Let's have it in full screen. All right. Let's zoom in a bit. Okay. So as I said, this is the whole profile. And this profile is represented with time-based, on the time base. So it means that here is the very beginning, and there is the end of the request. You can see here that we have a small red triangle here, which represents a marker. So here is the terminate. The terminate event. You can see here the fastest GI finish request, which occurs after the response has been sent to the end user. So here, each block which are piling down represents a PHP function that has been called. So we can see it, it as a reverse flame graph. Sorry. So for which the deepest we go, the more complex your application is supposed to be, because it's calling deeper and deeper components. So we can see here that simple Laravel application, it has already a lot of layers, many layers to the application. On the left, sorry, you can see different metrics that that compose your application, that have been automatically detected by Blackfire. So we can see here the bootstrap process, the database hydration, so hydration of eloquent models, all different middlewares like CSRF, the encrypt copy, the sessions, and so on, the router, and so on and so on. So all the colored ones here can be found there, and so we can have a look at what's taking time to be to resolve. So we can see, for example, here that the kernel bootstrap is quite long to render, to execute. Maybe we have something to that would help us speed up the process. And so that's pretty much it. We can filter the events. So it means that instead of showing all the blocks, we can actually highlight the colored blocks, or the featured blocks. So here, all the Laravel ones, to see what's going on in the most important components in your application. So like here, we can see that this is the threshold one. The threshold means that these blocks reach a threshold of performance. So it's basically Blackfire saying you might want to have a look at this one. So this is a compiled view here. And we also have a blue graph in the background. So this blue graph in the background represents the memory, the peak memory, which is increasing over time. You know, this one that once the envelope, the memory limit has been reached, well, it makes your application crash because it's way too much memory. And yeah, we can see here that, well, it's consuming quite a lot of memory. So maybe it will be interesting to understand why it's doing so. So that's it mostly for the timeline. Let's have a look now in other parts, other visualization parts. So here is the call graph view. I know it's it's zoomed out a bit. We'll zoom in after a few minutes. So you can see, actually visualize this call graph using the different dimensions I already mentioned. So the wall time, the IO time, CPU time, memory, and so on. So let's, for example, click on the IO time. And then we can see that we have a different visualization for this request. And same for if I click on the CPU, I will have a different one as well. Same for memory. And same for network. So I don't have any HTTP requests, but I do have SQL queries. So if I click here, actually, I will have the details of all the SQL queries that have been run within this request. And on the left side, you have all the function calls which are sorted by default by a percentage of exclusive time. You can change this on inclusive time or the number of calls. So here, if I click here, for instance, I can see that the function array merged have been called almost 7,000 times. So that's quite a lot, actually. And it leads me to something, to this notion of exclusive time percentage versus inclusive percentage. So if I click on this one, which is it's a carbon construction, carbon time zone construct. So the dates extension, the datetime extension from Laravel. We can see that it's on top of the list. So let's hover this. When we see here on the CPU, we can see that it consumes an exclusive time of 94.1 milliseconds, which represents 6% of the whole query. But if I take another one, like this one as datetime, we can see that it has an exclusive time of 31.8 milliseconds, but an inclusive one of 563 milliseconds. So that's huge, actually. So what's the difference? What's the difference between inclusive and exclusive? Well, the inclusive time represents the time spent within that function and included all the subsequent calls, all the calls that are below. So if I zoom in this function, so we can see that it's being called on a model, on an eloquent model. So the time here, the inclusive time, represents the time spent here, so on the node representing this function, and all the nodes below. We have quite a few, with a lot of function calls. That's a cardinality which is very high. The exclusive time, though, so back on the carbon one, represent the time spent only in this function. So if I take this one again, this function spent exclusively 31.8 milliseconds. So only for this function, and the inclusive is for all also adding the subsequent calls. So this gives us a hot path, actually. So having a look at the main wall time, I will reset this. You can see that just seeing the colors, following the colors which are fading, it represents the inclusive time, and you will see that in all different dimensions. So having a look, let's zoom a bit. We can follow this hot path, right? So each node here represents a function call, or here a group of function calls there, because it's all in the pipeline. We can follow this as following the right rabbit to see what's going on from top to bottom, until sometimes this kind of nodes, which presents a dark background. So this dark background versus the dark border represents actually the exclusive time, so the most intense nodes. So we can see that it comes from different PDO statements. So SQL queries, basically. Okay, so that's the first lead, the first clue for our investigation. We also have the same. Oh no, we didn't have ones for the CPU time, but we could still follow the lead, and we could see that actually it's coming from the comment as datetime, because the carbon is library is called below. And who is calling this? It's coming from the comment model, coming from a relation, right? So we have we might have actually an n+1 issue there, and where it's coming from, we can see here. So that's from our code, right? But it's being called by this this node and coming from this view. So that's interesting. If I click here, I have the details on the left. It's coming from our user activity helper, count recent comments for user. Okay, just keep it in mind for a few minutes as I going you through another the tour of the UI. So we have found something here. But first, before checking to the code, I wanted to show you this panel. So this panel gives us meta information of our application, of the page we've been profiling. And this, the most important is on the right with the cache information. We can have an insight of the level of cache that we have here for up cache, which, well, that's good news. It's activated. It's good. Well, we're not using it as a whole. The unturned string buffer, which is very important to have a look at, because it's keeping all the strings used by our application to reuse them. So if you reach the 6 megabytes, you really want to keep an eye on it in order to give enough space. The different accelerated files, the APCU memory, the real path cache, and the PCRE cache. On the left, we have all the meta information about the probe version and the agent version. So this is for Blackfire. The runtime. So sometimes you expect to have the appropriate version of PHP, but sometimes it's not what you expect. So it's good to have it here. DOS, the number of samples. So the samples are the different requests that we sent to the application in order to average the measurements. And here, I have something interesting because I forgot to disable Xdebug. So imagine that this happens in production. Well, you will have this big warning here. Okay, so maybe I can disable the Xdebug. Notice here the different tabs here. So we have a very useful one, which is recommendations. And we have, so for all paying plans, we have these recommendations. And we can see that we have a few about Laravel. Oh, yeah, Laravel configuration should be cached because we're assuming that we're in production here. So it means that we forgot to run this config cache artisan command. Let's click on this. And clicking on, you will have this documentation, small documentation on how to fix this this problem that Blackfire has detected. Okay, this one is very easy. We just need to run config cache. And same for the routes or the number of ORM entities. So here we are using the eloquent entities. We have also this here. So we have way too many entities. So yeah, we have now this very important clue about the number of entities. So it kind of confirmed this n+1 that we have. So now let's have a look at this problem that we found about the user activity helper counts recent comments for user, which have been called by this view from this user activity text helper. So back now to the code. So the user activity text was in here, activity helper. So I need to zoom. Not sure. Okay, cannot zoom here. Anyway. No. Okay. Let's switch to to presentation mode then. Okay, now I guess it's much better for everyone. So this activity helper gets user activity text. So it's getting a user. So maybe it's worth opening the. It's worth opening the template. So it's the citing one. I need to leave this. All right. So let's go to the citing controller. It's a citing view. Okay, now I have it. Okay. So this one, we are looping over the comments, and we're calling the user activity helper. Oh, my application is really slow. The user activity text. Okay, it's here. So we for each and every comment from the article, which we call a citing, we're calling this helper on the passing the owner of the comment. So that's why we have a user here. So we want to count the recent comments for this user. And based on this count, we will give it like a user activity text, so like a badge somehow. So the more they have comments, the more the different we will have as a user activity text. And if I have a look at this function, actually, yes, we call the different comments from the user. So we are lazy loading actually this property. We're loading every comment object, and if the creation date is within the last 3 months, then we count it. So that's a very bad counting algorithm. So let's change this to a more reasonable way of counting. So I'm just copy pasting here. So basically, I will here filter out with the owner ID and do a basic count, right? I have a lot of different noises here. Okay. So now I have fixed my code. So I I definitely had a n+1 problem. Now I'm just counting regularly, do a basic count instead of loading the whole the whole lot of comments attached to this citing. So now I have saved, and I will want to profile again so that I can see what's going on. First, well, I tested. I have no regression in terms of features. So now I'm going to profile again. Let's hope that it's not eating all my resources from my computer. I know that I'm doing this live, but remember, we have like 1 point something seconds. It seems that we did a good job here. Well, I can have a look first at the call graph and see, maybe having a look here. And we can see that, yes, we now have a count instead.